Welcome to the Destiny of Manufacturing podcast, powered by the Precision Metal Forming Association. I am your host, Dean Phillips, and I am so fortunate today to have our guest on from Stripmatic Products, Bill Adler. Welcome, Bill. It's great to have you on here today. So right off the bat, I always like to ask people, what is your big takeaway for the future?
Well, Dean, that was a great question. Again, thanks for offering me the opportunity to be part of the podcast. Um, when I thought about that, I thought in the next 5 to 10 years, a lot of our metal forming associates, we really need to be aware of this, especially if you're in automotive. Which direction are they going to pull? Are we going to go towards battery electric? And how much of the market can they be successfully, uh, accomplished in sales? And then, or how much are going to be retained as ICE engines, internal combustion engines? And then can they get to the point where they're going to use hydrogen engines? So those are, three options. And, if you're very tied into an internal combustion engine components, you've got to be looking at, what do we do? How do we reinvent ourselves in these other potential, modes of powering automotive?
Right. Now, just as a kind of historical perspective of where you guys started as a company and how this is why it's so important for you and for many of the PMA members and manufacturers as a whole, because a large portion of manufacturing is there and currently supports our automotive industry. So if we look at your evolution and where you are in making your parts, how does this play into your perspective of where you want to go in your future?
Well, Dean, over the 32 years my wife and I have owned Stripmatic, we've evolved quite a bit from, we were heavily into lawn and garden, off-road, big vehicles, and a small portion was automotive. And in the first 10 years, it really seemed that we fit more in longer run automotive type sandbox, those type of parts. And, we had a nice niche die system where in my business plan, I've got that we will only focus on tubular shaped parts out of a stamping process. So traditionally we used, mechanical punch presses, and we're evolving into, we've got our first multi-slide. But our parts, we typically ended up either on suspension parts for automotive, where they would mold rubber around our tube, and our tube would be the mounting spacer for the bolt that would go on the assembly, or the body. Then the other big market that we're in are in truck and SUV bolt spacers on their frames. So when they're assembling cross members or bumpers, on each end, they've got to torque a lot of components together with fasteners. So that's another area that we ended up specializing in, and we're a good cost savings over just cut off tube.
Gotcha. And now we had talked a little bit about that, and one of the changes is whether you're doing something that is a drawn part or whether it is a seamed part. How were you addressing some of that with technology?
Well, Dean, we sort of knew where our parts fit and where they didn't fit. And we found out there were a lot of parts where they needed to be like a seamless tube, or we needed to do a mechanical type fastening of our wrap tube. And we looked at the couple options there. We looked at TIG, MIG, plasma. None of them were fast enough to be economically competitive with cut tube until we stumbled on laser and had some great PMA friends that were good enough to open up their processes to us so we could observe how this was used. And it really, once we watched it in process, it sort of gave us the confidence that we could adapt this as another added value operation and get over that hump where we could keep that wrap tube mechanically connected when something's going to, let's say, cause pressure into the inside diameter of the tube where it would want to open up. And that's opened up a huge amount of new parts and processes that we were able to, that we're on now.
And when you talk about your, like, and you showed this picture here, which is your laser cell, tell me a little bit about how that evolved for you when you start talking about parts, because laser is that industry exploded over the last 30 years roughly.
Yep. Yes.
And in that time frame it has gotten faster, better, less maintenance. When companies like not to pick anybody by name, but most of the ones that were early on, they were debating technologies of flying optics versus moving tables versus everything under the sun. And the other aspect, of course, is cleaning the lenses and things like that. And how have you found that to be, as far as maintenance, as far as optimizing this as a solution using a secondary process? Now, this is your secondary process, correct?
Correct.
After it comes out of the press, things like that. So these types of technologies, how has that changed the way you look at your manufacturing, the way you find a solution? Has it opened other doors for you too?
Yeah, Dean, what we found, and again, once we realize we can be competitive by doing a laser welded seam process, then we dive in with both feet, and both the suspension markets and the chassis and frame markets, they're not really that big. So you really know who you're going to present this to and, see if you can pull them from a cut tube application. And a lot of times we can hold better tolerances, not in all, but a lot of them. We can hold tighter tolerances than cut tube. But then a lot of the tube is coming from offshore. So this created, we became competitive head to head against a lot of the Asian tube and tube fabricators. When you talked about, this is actually a picture of our first weld cell that I think we built this, it's almost 15 years ago now. And full disclosure, it doesn't look quite as clean as it does in this picture now. But, and like you mentioned, we learned pretty early about the laser maintenance, the lenses, the fiber optic cables. And again, we realized the laser part of our process is the most controllable, repeatable part of this process. Our problems are typically in part feeding and part handling. That's where we have most of our downtime, as we're tracking it. So the challenge is you throw, bulk loads of parts in a hopper, you're feeding those into that cell, that was an 18 station index table. You feed it in, and now we have to find the seam, rotate it to 0 degrees so we can weld right at 0 degrees. There you go. So yeah. we're not using all 18 stations. I think we're using 11 or 12. Uh, but we have two where we rotate the tube halfway around to find the seam. We have one fine tuned to get it right at 0 degrees. We index it to weld it. Then we have an inspection camera that tells us we have a weld. The weld is on the seam and there's no bubbles or splatter that would cause us a rejection. And then it gets good or bad part. So it's a very efficient cell. This, and again, this was our first, we designed this in collaboration with the machinery builder. So this is all custom. When we got another job that exceeded the capacity that we could put on this, our first laser. So Dean, if you want to go to that second, yeah, this is our laser 2. So we got a family of parts. We needed to weld 11 million pieces a year. And there were 3 parts, pretty similar, but you needed slight changes from one part to the next. So this cell, we took 2 horizontal tables, put them up next to them where they're vertical. So we're loading from either side and we're welding 2 parts at one station and then indexing. So we're doing all the similar processes, but when we looked at take fractions of a second off, this was the best way to optimize, the per part throughput. And to get us where we could weld 11 million pieces a year on this.
That is an impressive number. 11 million. And when you say that you went to a larger capacity, was it capacity on weight, speed, materials, temperature? What was the deciding factor of switching from one to the other?
Well, Dean, what we did is we started out with that first laser cell using a 2 kilowatt laser. Since then, we've upgraded to 4 kilowatt. And to be honest, it's really not a huge gain. The laser welds so fast. We do a 2 3/4 inch weld in 0.56 seconds. And it's, again, it's very programmable. We don't want to go all the way to the ends. So all this, you're controlling, in the program of the servo slide that we've mounted the lens on. And again, the changeover time of those 3 from one part to the other on the second cell, it's less than 20 minutes. So we're not changing out a bunch of fixtures. It's really the feed tracks and some inspection camera, that's just at the computer.
Right.
But this is, we try to commonize a lot of the sensors, the cameras, the rotate stations. We've commonized all those so we have a lot of interchangeability on spare parts.
Gotcha. Now, I'd like to ask you, when we talk about the technology itself, what has been some of the challenges that you've found with going to this process, and what were some of the solutions that you see, and going forward, even in the laser process that you've adopted, what are some things that some lessons learned and some best practices that you took away from this? I know that you've changed from materials now with, I'm sure like everybody else, it's more HSLA. How do you feel that has changed what you do or how you approach it?
Dean, it seemed like the automotive suppliers we dealt with, again, first and second tier suppliers, we don't sell anything to the OEs. They wanted higher strength, what we call axial load. So you put a tube on the end. If you can picture you're torquing a bolt down, that's an axial load. So they wanted to increase, again, it was a lot of light weighting, so they wanted to reduce the thickness of the tube wall, but they wanted to keep that column strength or axial load strength. So we started creeping up on the megapascals or the yield on the steel that we're buying. There are limits. We bumped into them, and like right now, we sort of know how far we can go uh, before the steel doesn't want to stay butted tight, before we can seam weld it.
I always noticed, when you look at welding, one of the things that happens is when you start to weld and you're trying to take two materials that haven't yet been joined, they want to retain some memory that they have within that material, and they want to go back to that form, whatever it is. They want to go back to that form, and when you start heating them, that really accentuates that. So I'm sure that that's one of the challenges that you at least had to dial in at the beginning. Was that something that you had to do by trial and error, or is the software now improved such that you can kind of dial some of that in to make sure, or is that more of a fixturing process?
Dean, that's a great supposition there. When we started welding these, and this is when we were trying MIG, TIG, and plasma. And again, when we cut and wrap that blank, we're putting tensile stresses in the outside diameter of the part. We're putting compressive stresses on the ID. There's a lot of stresses we just put in there. You're exactly right. We started applying heat, and it would want to stress relieve and open up. We can't afford that. It does now. So what we found with the laser, that heat is so intense and we can weld so much faster. The heat is just localized in just a very small area around the seam, and it greatly reduces that tendency to open up or stress relieve as we weld. And that's huge. I think if we were doing the other forms of welding, you're applying so much heat, the whole part gets hot, and you can pick up one of our seam welded parts like seconds after it comes out of the welder.
Yeah.
So yes, the laser allows us to minimize that just because of its intense heat and how quick we can weld.
Gotcha. Yeah, it's interesting you mentioned that, because not probably about 8 years ago, we took a tour at UT, the Space Institute here, who was working with NASA on several projects. And that was one of their things, was they went to the lasers because of exactly what you're talking about. When you start to have deformation because of temperature, you want to minimize that, and you can minimize in the concentrated point with the laser that you can't do in some of the other processes. So they really, it reinforces what they were seeing. See, you were ahead of the curve on NASA. So
they should have called us, Dean.
Next time, I'm giving them your number.
I'll be happy to make some missiles or whatever they're making.
Well, this is the space station, so.
Oh, okay. All right.
So with that, let's talk about, obviously we want to thank Stripmatic Products and yourself for being here, but why are you involved in PMA? What is it that PMA brings to the table for you?
Well, Dean, I that's a wonderful question, because I grew up in the steel mills. I worked on I actually prepared ingot buggies. That's how old I am. I took hot metal tests when they were pouring ingots under the ladle, and I held an oxygen lance in an electric furnace for a summer. So I knew the steel process up close and personal. I worked for a great small family business for about 9 years, but I was trying to look for an opportunity to get out on my own. I just by luck found a metal stamping company that was in distress. And it's a whole nother podcast on how we did an acquisition when you don't have any money as a 35-year-old. But I convinced my wife this was a really good thing. So we bought Stripmatic, and I knew steel, and I didn't know a darn thing about stamping and dies and stuff like that. Lo and behold, in our backyard is the national headquarters of well, it was PMA at that time. And they were so helpful. I joined, and some of the old guard were so helpful, so welcoming. And I could call some of the local guys. We bought our first press, new press ever. I didn't know if I needed a pit. I didn't have a lot of money to spend on engineering. And it was just a fabulous network. And now I know my wife and I have been really interested in paying back. So even though Stripmatic's not a big company, there's been a lot of people, that we've been able to help talk about our story and some of our challenges and how we overcame them. And I just came back from my CEO roundtable through the PMA. We have been meeting for 26 years, and it's one of the best values that a lot of us get out of PMA is this, there's like 18 of us or CEOs, all different industries, but we become incredible friends, but just great assets to bounce ideas or troubles off of each other.
Yeah. I think people don't understand when you're involved with an association, the value of the networking aspect. Because when you have resources that have experiences and in different ways, when we run the Link Safety School, everybody comments that one of the best parts of it is the time that they spend together. So, hey, what's going on? How are you working around workforce development? How are you working around training your people? How are you doing? It isn't just focused on one topic. It's very broad, and it's a great opportunity to really communicate. And when we've had events here in the Tennessee district for quite some time, the networking is invaluable.
Oh, Dean, I go back to the 2000s when we were first hit by the Asian imports. I mean, it was sort of a new thing to us back then. And the only way we're going to compete is by investing in sensor technology. Well, we ended up forming an informal sensor group of a lot of us just getting kicked off. And we got so much out of that. God bless him, George Kermedjev, who is our godfather of sensors. He connected a lot of us together, but that got us in the position where we could compete against Asia by having one operator run 2 or 3 presses now, where he had to be focused on one before we got a sensor package applied. So
yeah,
that was one example that really put us up into I think it could have saved our company when you talk about is that networking opportunity.
right. Yeah, that's a great point. Well, we're out of time here. Tell people how they can find you.
Oh, thanks, Dean. Yeah. Well, actually, I'm about 10 minutes from PMA headquarters in Independence, so we're very convenient. And I'd like to invite people, if you want to see our shop, just give me a holler. Our information's on our website. It's real simple, stripmatic.com. And actually, we have a video of Laser One running on that, if you'd like to see that.
Right.
But I'm at a lot of the events, the Forming of Our Future. I had a Miss Fab Tech this year, but I'm usually at that, networking a lot. So anyhow, I'm pretty easy to find if you'd like to talk or see some of what we're doing.
Right. And with that, I'd like to also thank the Precision Metal Forming Association for helping us put together this show. And one thing we don't often talk about is the one voice aspect, which is our advocacy communication system, where we talk about some of the challenges with overseas competitors and things like challenges of finances and things like that, which are really helpful. Of course, everybody should subscribe to the Metal Forming magazine because there's a lot of great information there. And if you are struggling, please look to the Metal Forming EDU. If you have a problem with keeping people or training them when they get there, look to the Metal Forming EDU because it's a great resource. With that, I'd like to thank you again for being here today. And thank you for taking time out of your busy schedule to be here, because it really makes a big difference to everybody. Bill, have a great day, and I'd like to thank everybody. Make it a great day.
Thanks, Dean. And again, thanks for what you do for the industry.